All right, welcome everyone. Thank you very much for joining me this afternoon. Did everyone like the party last night? It's good? I thought it was awesome. I don't know, thank you. I like the feel of this conference. It feels like an extended meetup, which really is cool. So I like these community ones. Let me introduce myself. My name is Seth. I'm a developer advocate with the Chrome team. A little bit about my background. I got started programming C, so I jumped a little in the deep end at the beginning, so I quickly found Java and really liked what that was trying to do. At that point, it really was embracing network computing. And I think at that time, and I still do, they have classes for URLs and moving bytecode over the wire. They had this whole applet thing, which obviously didn't really work out, but I really liked the idea of shuttling code around the web and object-oriented programming and garbage collection. So loved it and programmed a lot in Java. Moved on to Ruby on Rails a little bit after that. And then lucky enough to get this job at Chrome. But little did they know I was not a JavaScript ninja by any means. In fact, I think I let that cat out of the bag accidentally to my director. It's like, are you sure you want to hire me? But anyway, he was cool about that. He said, don't worry about it. So I got into client-side web development and learned all about the modern browser and HTML5 and found it to be pretty exciting, especially the pace of innovation there. I mean, we can hardly keep up ourselves with all the new APIs and capabilities of the modern web. But the whole time, I felt like I was missing something, and I was missing that programming experience that I grew up to love, the kind of structured applications or great tools that give me things like easy-to-navigate code or refactoring or interfaces and classes and type annotation. Just basically the things I grew up with, felt really productive with, I was missing when I was programming the browser. So when I heard about this project here, Dart, I jumped all over it because it allowed me to stay programming the modern web, but yet get that really productive experience that I grew up to know and love. So hopefully I can share some of the new features of Dart and share some of that story with you. Okay, well, what is Dart? Well, it's much more than a language. A lot of people know it's a language, but it's also a complete, essentially batteries-included platform to build modern web apps. So along with the new language that we built, there's a core set of libraries. There's a great set of tools like editors and analyzers. There's a custom virtual machine that runs Dart code. It's a brand new VM. But probably most importantly, Dart compiles to JavaScript. So the Dart code that you see today and the Dart code that I'll be talking about can run across the modern web on these browsers here. So I think that's really, really important. To give you a sense of the kind of reception that we've received and kind of frame the problem we're trying to solve, I want to tell a story here that we heard from a real customer using Dart. That he reached out to us, and we never met him, but over email, and he said, hey, let me tell you a little bit about how I experienced Dart. So he works at inside of a bank here in Europe, and he's a small development team. They're asked all the time to build applications, this, that, or the other thing. So pump out a lot of apps for internal customers. So of course, his boss comes to him one day, hey, we need you to build an app. He's like, okay, no problem. So the first thing he needs to do is go get require.js, because he needs to have some sort of requirement system. Then he needs backbone.js, because he needs some sort of modularity in the client system. Then he needs backbone marionette, because backbone itself doesn't do everything he needs. Then he needs jQuery, because every web app needs jQuery. Whether or not you import it or not, of course, it's going to be there. Then he needed Modernizer for feature detection. Then he needed Moment.js because he needed to parse some dates and times. Then he needed Dest templates because he needs some sort of client-side template system. Then he needed Phantom.js because he needs to do automated browser testing. Then, of course, he needs to get Jasmine because he has to write those unit tests and something. So now you can see this kind of teetering pile here, lots of different technologies. And of course, each one has its own docs, so he's got to figure out how they each work independently, how they format their docs, how they work. And then once he's figured that all out, then he needs to spend the time to actually integrate all this. And it's actually more complicated than it looks, even though it probably looks a little complicated here, because some functionality is duplicated across some of these libraries. For instance, some of these libraries might give you alternate ways to loop through or iterate things. So you've got to kind of reconcile that world when you compile all that. So anyway, it's totally possible. Obviously, there's a lot of people doing it, but it's a little teetery-tottery, and it's a little bit of a glue. He's like, I just want to write a web app. Why am I doing all this stuff? So he found the Dart project, and he could replace that teetering pile of technologies with a very stable collection of the Dart SDK and 3 individual packages, and they all just work together. And his feedback to us was, this is clear and concise. So I really like that feedback because that's exactly what we're trying to do. We're trying to make web programming a clear and concise exercise. But that's a developer much like you guys out there in the audience, but what about kind of the other side of the house inside Google? In Google, obviously, we make really big and complex web apps. Dozens to hundreds of engineers spread across time zones, spread across the world. Not uncommon to have millions of lines of code. So we've built systems, lots of layers, to compensate for this complexity and size. Things like Google Web Toolkit, I know a lot of people are familiar with, Clojure, Soy, and tons of internal tools. And it certainly has helped us get to where we are today. Gmail, Google Docs, Google+. These are pretty sophisticated and feature-rich applications, but the downside is low productivity. We don't really have a great edit refresh cycle, something that the web itself has had for a really long time. And I kid you not, some of the feedback that we get from the teams we work with before they started using Dart was, oh man, we've had 24 minutes between when I write the code and able to see the change. That doesn't sound very productive to me, so surely we can do better. Now, Dart is our effort to improve all the things, and Dart's not the first project out there to try to improve web development. Obviously, some systems you've heard before, Clojure, CoffeeScript, TypeScript, Google Web Toolkit, and some of these do a pretty good job at improving some of the dimensions we find important to web development, like structure, for instance, or tools. But we think Dart is the first one to actually improve, or at least not make worse, across all these dimensions: syntax, semantics, tools, core libraries. Importantly, does it require compilation for development? In Dart, no. Just edit, reload, and you can see those changes. So that's cool. So let's do a lightning tour through the language, the syntax, semantics, and structure, give you a sense of what Dart code looks like, how you might use it before we dive into the web development aspect of using Dart. OK. So simple syntax, ceremony-free. Here we are, curly braces, semicolons. It's funny because when we first launched Dart, the feedback we got was, oh, I thought you were going to build the world's next Haskell. And we're like, we want more than 5 users. So we picked a syntax that looks very familiar to hopefully everyone in this room and most developers doing kind of real-world web development. So you've got the class keyword, you've got your curly brace. Not only are we trying to make a familiar language, we also took this opportunity to make nice improvements as well. So this is one of them. What do you always do in a constructor, right? This.x equals x, this.y equals y, et cetera, et cetera. Well, in Dart, we said, hey, if the name of the field matches the name of the constructor parameter, that's fine. Let's make that simple. Let's say this.strength in this particular case, and this desugars into this.strength equals strength for you. So it at least cuts out some of the clutter you're probably used to. We also have named constructors in Dart. This is a nice feature. You can name methods pretty much anything you want, but constructors are typically named the name of the class. But we want a little bit more expressiveness. We want more information at the call sites. We allow you to create a named constructor. You still new it. So in this case, you would say new hug.bear, but you would get a bear hug, strength of 100. So I like that. Operator overriding, this is another great feature. A lot of scripting languages have this, plus, minus, et cetera, et cetera. Pretty straightforward there. You could do that in Dart. Optional named parameters. We also have optional positional parameters. The optional parameters can have default values. Again, kind of scripting language type features, yet in a nice structured language like Dart. One of my other favorite features, because Dart is a fairly terse language, it allows you to create anonymous or inline functions. And so you can create them with the fat arrow syntax. In this case, toString, fat arrow, string and braceometer. This is shorthand for curly brace, return, and braceometer, curly brace. So that's a nice improvement there. And another really nice improvement is string interpolation. So $strength in this case as well. So the toString methods, for instance, become very simple. Constructors become very simple. Hopefully this all reads to you pretty easily, and this seems like a nice improvement to the language we use every day. But Dart's its own language fully, and it's not just a syntax over another language. So Dart has its own semantics. And so we've taken this opportunity to clean up the what moments, that is the I don't even know what's going on there, to atomic, rock, nuclear, dinosaur moments. Those are the awesome moments. Those are the ones that you want. So some of the ways we've cleaned up in Dart, for instance, only true is truthy. There you go. There's the rules for truthiness and falsiness. Very easy. Nice improvement there. There's no undefined. There's only null. Nice simplification there. And probably the one that always confuses me, and we fixed in Dart, is there's no type coercion with things like double equals or plus, et cetera. So again, very simple. Normally, when you look at the code in Dart, it reads the way you think it's going to, which is a nice improvement. But let's look at what else we've done. So here's some Dart code, and you've got a string hello, and you want to call dot missing. Obviously, there's no missing method on the string. What would you want to happen in this case? Not a trick question. Well, you want it to give you an error, like right there when you run it. You don't want it to return undefined. You don't want it to keep on trucking. So in Dart, sure enough, when you call a method that doesn't exist on an object, you get no such method error. Boom. Very straightforward. What would you want if you access an index out of range error? Yes, exactly. You don't want undefined. You don't want to keep trucking. You actually want to know that there's a problem. In Dart, yes, great. We throw range error, and you know at that point that there was an issue. So that's a good improvement there. Okay, I'll let this one sit for a minute. Variable scope. All right, we've got a top level foo. We've got a function bar, and it's got a couple foos in there. And we have a main method. All Dart programs start from main, making it very easy to analyze. And we call bar. Now, what do you think is going to print? You think it's going to print undefined? Okay. Top level, that's right. No variable hoisting in Dart. A nice simplification there, and I'm really happy to see this. In fact, Dart has just lexical scoping. Just perfect, just easy. The way you read it makes sense. In fact, speaking of lexical scoping, even this is lexically scoped. So this is a thing that gets complicated in web development that hopefully is simpler in Dart. So here we go. We have awesome button, and in the constructor, we set up a listener. So when the button is clicked, we want to call atomic dinosaur rock. Now, notice this is lexically scoped, even inside that anonymous function that we give to the button listener. In JavaScript, for instance, you'd have to say var that equals this, that dot atomic dinosaur rock. And again, new developers don't understand this. But most developers would look at this code and be like, oh yeah, of course it's supposed to work like that. So hopefully a nice improvement there with pure lexical scoping, even including this. Okay, so that's a little bit about the language, syntax, and semantics. Let's look at the structure that we're offering in Dart. We've seen examples of functions and classes already. I want to show an example of libraries. This is something you get out of the box with Dart. Libraries, very flexible. They're just a file. You just simply define library at the top, in this case games. You can import other libraries. You can import the included SDK libraries like math. You can import other people's libraries simply by pointing to them as a file. And inside a library file itself, you can define any number of constructs. You can define any number of classes, top-level functions, top-level variables. Very flexible how you arrange on the source code level your libraries. In fact, Dart doesn't force you to create one file per public class. You can put many. You can create one library file, put your 7 classes in there, ship that as a nice source file. Very simple, very flexible. Okay, what's new? In the language. All right. So here's something we do all the time in DOM programming. You will create a new, say, button element, and you got to set it up. It's like a builder, right? You got to set the ID, got to set the text, got to set the classes, et cetera, et cetera, et cetera. There's way too many buttons here. There's 6 buttons repeated over and over. Now, in Dart, we took a cue from Smalltalk and introduced method cascades, one of the new really cool features in the Dart language. We said there's really no reason to repeat that variable over and over and over. So use the double dot here, and each one of those following expressions is applied to that first expression, and then that whole thing is wrapped up and returned to the variable. So right there, much cleaner. And the nice thing here is that all APIs in Dart can take advantage of this. You don't need to design your API to return this and get chaining everywhere. Because this is at the language level, any API can take advantage of this style of programming, which I think jQuery has made pretty popular. But we can do a little bit better. Notice we still have to create a button here. We can inline this completely. We can say, I'm going to add a new child, I want to add a new button, and I want to configure that button right where I'm adding it, which is really nice. So this may be a little bit of a complicated example, but I do a lot of times I'll say new div ... ID and then just give that to a function call. So I don't have to introduce a whole new variable. And so it's nice to have these kind of features baked into the language. Okay, I hear a lot of talk about databases and ORMs at the conference. So maybe you've seen class hierarchy, something like this. But one of these things is not like the other, right? What's the problem with this kind of design? Anyone? right? So persistable, hug is not a, is a persistable. And you really want to use your inheritance trees, your type hierarchies for is-a type relationships. But of course you want hug to be persistable, have the characteristics or behavior of persistable. So can we do this without polluting that inheritance tree? Well, thanks to mixins, another new language feature in Dart, you can. You can take persistable, that is like the behavior, and mix it into a class so it doesn't pollute that hierarchy tree, and you still get that single inheritance down the things that really are is-as, which I like. Now, mixins are very simple. We didn't have to introduce a whole new concept here. We just said, well, actually, if you think about it, a subclass, when a subclass is a superclass, that delta, that difference, is the mixin itself. So we go ahead and use abstract classes here to define the behavior of the mixin. So we just kind of play off of features that already existed. In this case here, persistable, it can define save and load, but it defers to JSON to some other implementer. And we apply the mixin here with persistable, and notice how hug here implements to JSON. So he's got to define, what it is that he's persisting. And we use it very simply right here in the main method, create a new hug, and then hug.save, even though that save method came from persistable. It looks like it was in the class all along. So mixins, pretty nice. Another language feature we've added over the last, 12 months or so is metadata. That you're probably used to this as well. Dart has this really nice for just teaching your tools about the program itself. So in case, a good example here is deprecated. I think we all know what this is going to do, and our tools can read that. But the neat thing about Dart is that you yourself, it's very easy to define your own metadata annotations. So I'm going to use this in-progress feature called lazy loaded libraries to illustrate how this could work. We're going to create a const object here. Const lazy equals const deferred library. So we're going to say, OK, there's this thing called lazy library out there. Then we're going to apply that as a metadata annotation here. And we're going to say, this import to mylib is lazy. That is, I want to pull this in later. And I want to use it here. I can say lazy.load. And again, notice how I'm actually interacting with that const object that I both created and am using as the annotation. Say .load, which will go ahead and run the network connection, and at some time later that's going to return. So I wait for the future to complete, and then I can use the features in that lazy loaded library. So I like this as just an example of how you can define your own metadata annotations, and then the tools, for instance, Dart to JS here, can read through your whole program, still perform tree shaking, still output a nice, efficient application, but say split it up based on how you've defined it. So you have one main JavaScript file, and then you have a lazy loaded other JavaScript file. That all works today, and it's cool, thanks to metadata annotations. OK, moving on. What's newish in the libraries here in Dart? Well, the first question we always got when we first launched Dart was, this is totally cool. I love it. I see what you're doing here. But I've got a lot of JavaScript code, and I need to access that. So how do I do that? And I'm happy to report that we can totally do JavaScript interop now. So how do we do it? Well, we needed a solution that can work in one of two ways. Both when you compile the application to JavaScript and when you run in a multiple virtual machine world. If you remember, one of the features of the Dart project is its own virtual machine. So we envision a day where Chrome is running V8 and Dart in the same page. So we need a way for those two objects to talk. But it also has to work when you compile the whole thing in JavaScript. So we built this proxy system that can proxy both objects back and forth as well as callbacks back and forth. So I want to give you an example of Dart code that uses JS proxy and the JavaScript code. And I think you'll see that they're fairly similar. So there's not a lot of cognizant overload here. So the first line here, go ahead and get a reference to the API object. Then create the data here for this bubble chart API. And I notice I need to wrap the data, the raw array, in a JS array. That just makes it a lot more efficient to transfer back and forth. Then get a reference to the actual bubble chart object itself. In the Dart world, we need to get a proxy to that. But once you have that object here, it's very simple and straightforward to call a method here, chart.draw, and that's identical code in the JavaScript world and the Dart world. So it's almost line for line, one for one. So it's pretty nice here. But I want to show a real-life example of this just to prove that it totally works. So I don't know if you guys are familiar with Sencha or Sencha Touch or XJS. This is a pretty rich framework that you can build client-side web apps with. It's fairly complicated because there's so much functionality there. And so I wanted to prove that you can merge in Dart code with an existing JavaScript app working already with a fairly full-featured framework like Sencha Touch. So let me go over to Dart editor here. And Dart editor, it looks like Eclipse, but funny story, when I first showed somebody the Dart editor and pulled up the preferences, they're like, oh, dude, there's a bug. You're missing like 80 more preferences. And so, no, actually, we simplified it. Don't worry, this is the simple version. So this is an editor built from the ground up to help you write Dart code. We also have plugins for Vim and Emacs, and the JetBrains guys are cool, and they have a plugin. And so hopefully there's something that works for you, but we'll just stick with this for now. Here's the Dart code that powers that Sencha Touch Dart interop mashup. So there's a lot going on here, but I just want to point out two things here. Here's the use of a proxy to get a reference to a Sencha button. And notice how I use the cascades here, set text and set handler, to go ahead and interact with that proxy, even though this is a dynamic object. But the neat thing here is in set handler, I'm saying, OK, I want a callback that comes from when the button in JavaScript is clicked, but I want to run this Dart code here that itself then creates a new message from the Sencha app world. So I'm kind of going back and forth in multiple ways. So I think I have this running here. Hopefully you can see this. This is the JavaScript side of the application, but I've created this page here. No, go over here. I've created this page here in Dart code. And when I've created the button, I click the button, it goes through JavaScript, back to Dart, back to JavaScript, and sure enough, it all works. So it even works on the phone. You guys probably can't see this, but it's really cool. So this is an example, again, of a JavaScript app built with some Dart in the background, and it all works. So it's cool. Hopefully this is a good way for you to start using Dart in an existing application. What else is new in the libraries? Well, we've all heard the horror stories of callback-heavy web development, right? It's callback hell. They get nested. It's hard to understand the control. Surely we can do better there. So we've taken a cue from other libraries and languages, and we've integrated as first class into the core libraries futures and streams. So let's look at futures, which I think can take us from this fire and brimstone to this beautiful beach here. So. All right, so here's the horror story, right? And maybe you've seen code like this before. Get cat data, then that takes a callback, and then you want to get the cat pick, and that takes a callback, and then you want to rotate it, and that takes a callback, and finally draw 4 levels deep. I don't know about that. And then if you add error handlers, yikes. So this is really, really gnarly. Well, I'm happy to report that the future looks bright if you use the future construct. The future being an object-oriented representation of a callback. It's a promise for a future to be available in the future. So instead of taking a callback here, each one of these methods can return a future object, and futures chain beautifully. So what used to be this is now this. Get the cat, then get the cat pick, then rotate it, then draw. And if any of those throws an error, catch the error at the bottom of the chain. It almost reads imperatively in order, yet it's all asynchronous. And you have nice consolidated error handling at the end. Futures also compose really well. So here's an example. Let's say I want to get 2 cat pictures, but I want to wait for both of them before I continue. No problem. Futures.wait, multiple futures. And when they all complete, then go ahead and continue with the work. So they chain really well. They compose really well. They're object-oriented. I really like them. But futures are for single events, single value in the future. What about things that repeat? How do we have a good asynchronous answer to that? Built in the core libraries is the concept of streams for a series of async events. And the nice thing about this is we've permeated the streams throughout the libraries in Dart. When we launched, we didn't really have streams. We had all these different ways to kind of handle events, and we've unified everything together, largely in part due to feedback from people using it early. So everything here, from bytes from a file to events from the DOM, even button clicks, incoming connections on your web server, all these things happen repeatedly. They all happen via streams. And streams are very easy to use here. Stream.listen, and then here you have the inline or anonymous function, event, do something on that event. Pretty straightforward, but streams compose really nice as well. So on key press is an example of a DOM event. It returns a stream of keyboard events. So let's look at how I might use this to work with, say, key presses in a DOM app. Query for the text area on key press. OK, streams have a nice filtering. So where the key code is between these values, and this returns another stream of filtered key codes. Then I want to turn those key codes into actual strings. So map or convert all those, which itself returns another stream. And then I really only care about the first keystroke in this particular example here. So I want to turn that stream into a future by returning the first event as a future. And then when that feature completes, go ahead and print it out. So it's a good example of how chainable, composable, and convertible streams can be. OK, cool. Speaking of DOM, let's look at what's new in HTML programming with Dart. Well, we've talked about a lot of different features, both the language level and the library level. And I want to show you how they're actually applied to make it easy for you to build web apps. Because at the end of the day, what we're really trying to do is help all developers from all backgrounds, Java, C#, ActionScript 3, JavaScript, come to the web and build awesome apps. And that means taking advantage of the wide array of HTML5 features that are out there. But we don't want new developers to the Dart platform to learn all about Dart and the language and then try to build a web app and have that experience be totally different. So we've created a Dart HTML library that sits on top of what the browser gives you and makes it look and feel just like Dart code. So we've Dartified building for the browser. So we've improved on the DOM. All the capabilities are still there, just it looks like Dart code. So here's a good example of something that can be fairly complex. Let's do get user media, which is how to get access to the camera and microphone that's available via your hardware. So we're going to point out a couple features that we use. Named optional parameters. So do you want the audio? Do you want the video? These are optional, but of course it's baked into the language, so you can code complete this and understand what the parameters are that you can pass into get user media. Then, so this returns a future because it has to ask the user, is it OK if this app accesses your hardware? So we wait and wait. And when they accept, the then completes. And we're going to create a new video element and use method cascades to set that up. And then we use a stream here, so on loaded metadata. When it's all loaded, we're going to append that video tag to the actual body. And that video tag is what's surfacing what you see in the microphone and camera. And then, of course, if something fails, we catch error at one place and one place only at the end of that chain. So we use streams, futures, optional name parameters, method cascades here, all to help you access the hardware available in modern web apps. And it looks like Dart code, so that's cool. OK, this is funny. So funny. Thank you. What are we doing here? We're building an Ajax web app. Sorry. I should not drink while I speak. OK, let me try again. This is a funny story. Well, everyone knows XML HTTP request, right? When's the last time anyone actually sent XML over XML HTTP request? So we dropped the word XML and made it HTTP request. It's definitely simpler that way. But we also made it look a little bit more like jQuery, which completely simplified working with Ajax applications. For instance, if you can just call request and ask for a URL here, you have a bunch of named parameters, methods, send data, request headers. Again, if you're familiar with jQuery, it probably looks something like this. But then here we go, futures again. So when the request finishes, then I can go ahead and parse the response text. So I think we've cleaned this up as well. I don't know if you're familiar with the raw XML HTTP request method, but it's kind of confusing. So I think this works better. Other new stuff that we have here, well, event source mapping. So you can set an on-click handler right at the top of some DOM tree or even the body, but you say, I want to only handle events that match a particular CSS selector. So that's kind of cool. People like this because they might be dynamically adding or removing nodes from deep in the tree, but you want to have only one click handler, for instance, at the top. Use the matches CSS selector to get only the events that you care about, even though you might be really high in the tree. This is brand new. This is awesome. Who knows why this is bad? Obviously, it's red. The script tag, right? So typically, web apps, they're going to let you do this just fine. And if you insert strings that have a script tag right in the inner HTML of your application, whoa, you've just XSS'd your app. And that's obviously really bad. But in Dart, I'm happy to report that when you set this now, we prune out things that may be dangerous. And the only thing that gets inserted here is the safe P content. This is a huge improvement, safety and security by default. You get for free in Dart. Now, of course, there's ways to configure all of this. You can create your own whitelists or blacklists, et cetera, but the default behavior now in Dart is to strip out potentially dangerous things. This is a really nice improvement. OK, cool. So let's move on to the really exciting thing, the real bleeding edge, because why talk about one totally awesome thing that is Dart when you can talk about two awesome things, because that's Dart and web components. OK, I like to set it up like this. The version on the left old and busted. This is actually Gmail code. Total mess. I mean, no semantic information there whatsoever. Really hard to debug. Who knows where the actual message is? And the version on the right is the promise that Web Components aims to deliver. I don't know which one you guys like. I like the one on the right. It's very clear. It's concise. It's semantic. It's encapsulated. It's easy to debug. That's the one that I want. And Web Components is aiming to let us create actual new HTML elements, extend the lexicon of the DOM, and give that power to developers. You can avoid the div soup here on the left. So there's many benefits to this whole Web Components movement, which itself is a family of new specifications. One of the really nice benefits is encapsulation. So when you create a custom element, a custom HTML tag, you're encapsulating three main things. You're encapsulating the structure, or how you build up the one tag out of other tags. You encapsulate the behavior. That is, you can add new imperative APIs to a custom element. And you're encapsulating the styles. So imagine being able to set CSS styles relative only inside of a custom element. That's huge. Today, when you inject HTML or CSS into your page, it just bleeds all over and affects everything. There are no boundaries. Web Components will give you those encapsulation boundaries. Web Components are also reusable, an actual kind of shareable widget system. So create or define a custom element once and import that into multiple HTML pages. Whoa, this is awesome for web development. Something other frameworks have had for like 10 years, but we're going to get it on the web. Also inside of these kind of application frameworks are real live data binding. So when a model changes, update the DOM. When the DOM changes, update the model, update other data models. It all just works. And the nice thing is this is all built on emerging web specifications. So the functionality I was just talking about is available via these low-level primitives that are landing in the platform as we speak. In fact, it's great to see that multiple browser vendors are really excited by this. Firefox has some polyfills for these functions. Chrome has some polyfills for these functions. Microsoft is quite interested in this work. So it's really nice to see everyone come together. I think that means we're on the right track here. So you might, when you hear about web components, you might hear words like HTML imports or shadow DOM or the template tag. These all kind of compose together that family of specs all under that umbrella of web components. Now, they're kind of low level. I'll show a little bit about this, but it all kind of permeates to the top in custom elements, which we'll take a deeper look at. But it's kind of nice to know what's going on under the hood. So one of the new features is a template tag. Templating is not a new concept or concern for web developers. We've been trying to do templating for a really long time. Some crazy hacks, like you could put it in a script tag or something and try to parse it out and put it back in. Well, the template here is now a first-class actual template defines inert set of DOM. That is, the browser will actually parse this and create, like you can find that template tag as a document fragment, but it doesn't instantiate it. That is, he won't even try to download the images, the URLs bound into images. So it's a nice way to create these inert templates inside your DOM. And then if you want to go into the low level here, you can use the DOM APIs to find that template element, clone it, and the only thing that's important here is to know that you can clone the template and then insert that clone template else into. And that's kind of how you stamp out new live DOM subtrees from a single template. So we use the DOM, we use HTML to define templates. This is great. Use what we have. Shadow DOM is another kind of low-level feature. This actually gives us those encapsulation boundaries. Now you can see here it's an HTML5 video on the left, and you might be thinking that this was some C++ widget or control somebody built, but it's actually a video element made out of other div elements, other DOM elements. And so browsers have had this capability to build DOM out of DOM for quite a while. So I used the web tools, the developer tools to inspect this element. And then you'll see this document fragment here. When you open up document fragment, you'll see all the div nodes that the developer used to build the actual video tag. But it's hidden behind the shadow DOM. So when your program tries to walk the DOM tree or you just view source, all you see is video tag. But remember, that video tag is built out of other DOM tags. Shadow DOM just standardizes this behavior and gives that power to developers themselves. Here's another way to look at it in the abstract here. The green is a normal DOM tree that you would interact with or walk, or the user would see if they viewed source. But you can see here the shadow host, which is the node that hosts the shadow DOM, is actually composed out of this shadow tree itself of other DOM nodes. So when you actually render out the real live DOM, this node here is manifested as the rendering of the pink nodes on the right. So again, it allows you to encapsulate that structure of a DOM node as it's built out of other DOM nodes and present it as a single video tag. Or, with web components and custom elements, your own tag. Which brings us to Polymer. So those were some of the web specifications in the works right now, but you know, web specifications take a little while to actually land in all the browsers we care about. And we're impatient. We couldn't wait. So we built the Polymer project, multiple levels here, to give you the power of web components today, both polyfilling it at the foundation level and providing value-add elements and app frameworks on top of that foundation. So this is a really interesting project because, again, it gives you the power of web components today. And as a Dart developer, we are, alongside with the Polymer folks, porting Polymer to Dart, oddly enough, named Polymer.dart. And today we'll work on the foundation and the core levels, giving Dart developers the ability to build custom elements today. So what does this look like? Well, we have the Polymer element here. And again, we're using HTML to construct new HTML. In this case, it's a click counter. Well, remember, custom elements encapsulate structure, styles, and behavior. So in this case here, we're going to talk about the structure. We use that template tag that we saw before to define the structure of a Polymer element. I'm going to say, well, I want a click counter. I need a button so I can click it. So my shadow DOM is composed out of a button. But here I also have declarative event handling. So when this button is clicked, call the increment method, which we'll see in a moment. I also care about the, I want to print out what the button is doing. So you click the button count. Now notice how count is wrapped in double curly braces. This is other data binding in action. Whenever count itself is updated, update this part of the DOM right here for you. You get that part for free. And remember, I talked about custom elements have structures. So we looked at the template. They have their own behavior. So that's where the script tag comes in. So we're going to create a Dart class that backs this custom element. So you always have the Polymer element in HTML for the structure and styles. Then you have a Dart class here for the actual behavior. So notice here I've got count and I have increment, both things I referred to in the HTML. And we have direct data binding. So the fields in the class are available to the data-bound expressions in the custom element HTML itself, which is kind of cool. And how might I use this? Remember, we talked about imports. I can import this file here, and I can put this Dart code right in the script tag, making a single file either way. I can import it here with link rel import. Again, using the features of HTML already. We already have links, the capability to merge up pages. Now I can do it with actual custom elements. And I use the tag here, click-counter, extending the lexicon of the DOM. And now I've created this reusable click counter that any other app can just import and use, and it's just awesome. OK, so what else can you do with custom elements? That was very simple. Click a button, show the results. We have conditionals. I think most templating or frameworks have conditionals. We do this with the template tag itself. If, run some expression. If returns true or false, render or remove the contents of that template from the DOM. Pretty straightforward. We also have the concept of loops. I may want to repeat the instantiation of a template over and over and over, once for every item in a list. Like example here, I have a list of fruits in my custom element backing class. And for every fruit in here, render out template li. I like apples, oranges, and bananas. OK, pretty straightforward. But I want to show you a slightly more complicated example here, just to show you that it all works across multiple browsers. So let's go here back to Dart editor. Here's the main index.html for the to-do app. So notice how it all starts with an element. One of the things that Polymer really believes in is everything is an element. Everything is this custom element. So to-do app, boom, we start there and we say, OK, well, that's been imported from to-do HTML, so we can look at that. And sure enough, we have a Polymer element. Now remember, I talked about encapsulating the styles. So I have CSS rules that apply only to this custom element. And notice how I don't have to qualify them. It's really, really nice. I have other structure we don't have to focus on, but sure enough, data binding here, how many remaining to-dos. Here's the template repeat. So you can see all these features that we looked at, all right here as an example. So let's go ahead and run the application. And to show you that, let's see if I can increase this. Yeah. So this is Firefox. I'm showing this for a couple of reasons. One, even it's a Dart app and it's a Polymer app, it all compiles down to vanilla JavaScript and HTML. And running here in Firefox, which has no knowledge of Dart, doesn't have a Dart VM or anything. So this shows you how you can write modern apps with a modern language like Dart, with a modern toolkit and framework like Polymer, and still deploy them to the modern web across modern browsers today. So it all works. So go to JourneyZone. Sure enough, there you go. And it's cool because I didn't have to write a lot of the infrastructure connecting code. I simply said, I have a custom element, he has some fields, and I have some data binding, all declaratively. And the framework here takes care of wiring, finding the DOM elements, setting up all the event handlers and listeners, and destructing all those, all done for you. So I have a really productive time using Polymer and web components, building web apps, and we think it's the future. Okay. So we talked about this, and you can see it at Polymer-dart. So it's out there for you guys to use. OK, as I wrap up here, what's new in size and speed? Well, the Dart project was co-founded by Lars Bach, who helped start the Hotspot project. You guys are probably familiar with that in the JVM. And the V8 project, which you might be familiar with as Chrome's fast JavaScript engine. So if anyone knows how to make systems go fast, it's these guys working on this project. So I'm really happy by that. And what have we done lately to help make that come true? First, I'd like to remind everyone that the web is hungry for speed. And a lot of people might think, oh, I thought web apps were fast these days. I mean, don't we have like faster computers? And isn't V8 and all them pretty fast now? But let's go back to before V8 came out, for instance. People thought the web was totally fine. In fact, people didn't understand why we were building a new fast JavaScript engine. They thought, oh, web apps are fine. Like, why do you need to innovate here? And we launched V8 sometimes on some benchmarks 1,000% faster, 1,000 times faster than some of the previous benchmarks. People then the light bulb started to go off, like, oh, I can actually build really, really full-featured applications in the browser now. And that kind of spawned this wave of multimedia applications or Google Docs or Street View and Google Maps. I mean, this is all running JavaScript in the browser. And this was just the first wave from the first speed generation. Now imagine if we could say, oh, now program in Dart and get 2x maybe performance. What new applications can we develop? What new experiences can we deliver? And how can we wow our users? So it's no problem. We'll give you developers as much speed as you want. You guys are going to take advantage of it. But it's not really just about being able to make really awesome experiences. Of course, that's good. But it's also about this right here. Right? This time next year, most of us will be developing for mobile first. Mobile searches will eclipse desktop searches soon. More tablets and phones are being sold for them PCs. And I want to make sure we don't miss this boat here, because if we do, then our competitor will find a way to make this experience really fantastic. But what do you not see here is a cable, right? So it's about battery life. Every CPU cycle you can save some battery here. And that's really, really important to us. So we think better performance equals better battery, happier users. Okay, so what are we doing to make things smaller and faster to get us there? Well, Dart.js is the compiler that takes Dart code and outputs JavaScript. It's maybe the most important thing we do in the project. And Dart.js itself is written in Dart. I think it's like 70,000+ lines of Dart code already. It's a pretty significant app. And it does some pretty smart things with the JavaScript that it outputs. It does tree shaking, minification, and type inferencing. So we'll look at some examples there to take your Dart app and actually output some efficient JavaScript code. Here's just an example of a very simple Dart app. Let's see, a person class, and we use it in main method, and we query for some DOM element, and we set its first name. When I compile this to JavaScript, I get pretty much one-to-one line mapping here. Now, this is really cool. This means that the JavaScript that we output isn't totally obfuscated. So you can basically read this and say, OK, I have an understanding of how it's going. And that's OK for development and debugging. And we output source maps as well. So you can debug the Dart code, and Chrome's dev tools will actually map a breakpoint from the Dart code back to the JavaScript code that's actually running to make a pretty decent debugging experience. But when you want to ship to the wild, you want to minify. You want it as small as possible. In Dart.js, because he understands the full nature of your application from start to finish, can do a pretty good job at minifying. So the code there at the bottom is the minified code. So that's good. We have to get things small. There's another strategy, though, to getting applications really small, not just minification, but tree shaking. So this is really cool. In fact, if you think about, this is a major advantage of Dart as compared to, say, JavaScript. And you think about the main marketing message for a lot of JavaScript libraries out there, they all tout how small they are. You've got jQuery's 30K, gzipped, then you've got like Nano and Femto and Zepto, and everyone's just trying to get it as small as possible. But of course, when that happens, you lose functionality. You got to throw things out the window. So you probably have to go get another library and put that in, and you end up with essentially the same size. Well, I want my tools to do that pruning for me. I want to be able to import a library. I don't care how big it is. I want to use its features and then have the tool, the build process say, oh, so you're not using that, you're not using that, you're not using that? Fine, let's tree shake that out. So here's an example at the top. I have a main method. It uses one function. It imports a library, uses one function from that library. I run it through a tree shaking compiler like Dart to JS, and he outputs only the code that's required to run the application. The tools do this for you. This is awesome. So I just love this kind of tool productivity, and I don't have to worry about it. I can just import libraries that are useful to me, that have good unit tests, that do good things, and let the tool realize the parts that I don't use. Okay, so that's a little bit about Dart to JS. What are we doing on the Dart virtual machine to make our users happy? Well, that's speed. Now, the nice thing about the VM is it's a fresh approach. A lot of people are like, why don't you just kind of extend V8 and make that run Dart code? Well, V8 has been optimized and optimized year after year, benchmark after benchmark, to run JavaScript code. But Dart is more structured. In fact, in Dart, we have explicit and static structure. Once you compile that program, it doesn't change its structure. Real classes, real arrays, no prototype chain to check. Globally tracked field types, a whole bunch of other optimizations we're able to put into Dart, the Dart VM, much faster and quicker because we have much less baggage. So I like to think of, before you've got this guy lumbering around with all this baggage coming along, but then the Dart VM, you've got this guy zooming on this like luggage scooter thing, and that's kind of Dart VM there. The other nice thing about the VM is not just a fresh approach and that can take advantage of the new structured language, but we're also able to unlock whole swaths of transistors on your CPU that you have never been able to access before. And remember, every CPU cycle counts and saves battery. So for instance, because we're able to kind of able to move fast, we can say, oh, well, what about SIMD, which is a great optimization for things like physics and fluid simulations and games. And so what is this, like 20% of your CPU in this ARM CPU here is SIMD instructions that you literally can't access? Well, in the Dart, we've made that available to you, so you can write applications that run up to 4 times faster depending on that algorithm, but basically saving 4 times the amount of CPU cycles, which is a huge battery saving. So how does this translate to real life? Well, here's some numbers we ran, well, actually a couple months ago now. And the blue line here is the Dart virtual machine. The gold line here is handwritten JavaScript, and the green line here is Dart code compiled to JavaScript run on V8. And you can see in one particular case, the compiled to JavaScript version is just slightly faster than the handwritten version. But in all cases, the Dart code running on the Dart virtual machine is up to 2 times faster than the handwritten, hand-tuned JavaScript. So we think we're on the right track. There's still a lot of work to do. But again, the guys that are building this have a nice track record on building fast systems for us before. So I like that. But this is on this really beastly machine here, right? So how does it translate to something like this? Well, I'm happy to say that the performance characteristics translate very well. In fact, here's a different benchmark here where we do handwritten JavaScript, Dart running on the virtual machine, but then here's Dart running on the virtual machine with the SIMD instructions as well. So almost 2.5 times faster on this particular benchmark here, showing significant gains if you use all of your CPU and all the libraries available to you. So I think you guys are going to like the power that the system gives you. But this is Dart is a big platform, and it would take many, many hours to cover it all. So unfortunately, I had to skip a lot of stuff that might be really interesting. Things like reflection. There's a whole API for reflection. It's called mirrors. It allows you to reflect on libraries and classes and introspect at runtime or at source time. Also, dynamically call methods for you. We have a whole server-side story because the Dart virtual machine can run on its own. You can just run it on the command line like you would Java or Ruby or Python. So we have classes for WebSockets and HTTP and files and directories. We have a whole package manager. I think over 400 packages already in there, ranging from server-side to client-side. We affectionately call it pub. Editor support, we didn't go to any of the features like refactoring or renaming or find an app. It's a pretty productive tool. Testing, we give you unit tests and mocks out of the box. And then a really cool thing is concurrency. Our concurrency model is based on isolates, which are shared nothing isolated memory heaps where you pass messages back and forth. So no shared state threads in Dart, much safer concurrency model. Kind of takes a cue from Erlang actors, for instance, and there's a ton more. It's really easy to try Dart. Hopefully you guys give it a shot. It's an open source project. It's on GitHub and Google Code. We have active communities on Stack Overflow and Google+. So there's lots of ways to get involved and reach out to us if you have questions or feedback. We're barreling towards a 1.0, so if you guys try it and want to let us know how it worked, this is a great time to do that. So the main thing to remember from this presentation, hopefully, is that Dart, we have a stable language and stable core libraries. So it's a good time to try Dart. Dart compiles to JavaScript. So everything we saw here today runs across the modern web. We saw that demo running in Firefox. It's an evolved platform. We've been open source since October 2011. I've gotten a ton of feedback. We've got internal customers using it, external customers using it, tons of feedback going in, good cycle there. And so what you see today is others have paved the path for you. So hopefully you'll have a good, productive experience. And Google is committed to Dart. Again, we have business-critical internal applications being built on it. You can look at the talent on the team, the fact that we're inside of Chrome. Our whole mission is to make web programming better. And so it's good, and I really like the trajectory that we're on. So with that whirlwind tour of what's new in Dart and some web components demos, I want to thank everyone again for joining me this afternoon. I really appreciate it. Feels like I'm talking to kind of a hometown crowd, so I really like talking to Java developers. So that's cool. I'll hang around for, we have a couple minutes for questions, and I'll hang around. So again, thank you. Enjoy the rest of the conference. And if you come to San Francisco, look me up. So thanks. Does anyone have any questions I can answer for you? Did it make sense? Anyone want to call me out? Anything? Okay, well, feel free to come up to me and I'll help you out. Thank you.